Hey guys, Ray from Love You RV. So today I'm going to give you a look at my new power inverter that I bought. It's a 3000 watt pure sine wave inverter from a company called Canadian Tire. It's a big chain in Canada, very popular. Does a lot of automotive sales and all kinds of stuff. It's kind of like a big hardware store. Anyway, my original inverter that I got when I got the Cougar fifth wheel was a Motomaster Eliminator pure sine wave. It was a 1000 watt, and it's still humming along 11 years later, so I thought I'd give them another try. Now they're fairly inexpensive as it goes for a 3000 watt pure sine wave. You can spend an awful lot of money, but I didn't want to spend too much, because not only is it going to be used in my RV to power stuff, but I'm also going to use this as a test equipment, because I've been reviewing a lot of these new lithium batteries, and they can put out an awful lot of current, up to like 200 amps, some of them. So I needed something that I could use for power testing those batteries. And with this, it can take up to 300 amps. So I'll be able to utilize it as a good piece of test equipment. So I don't want to really, spend $1,000 or $2,000 on an inverter and then blow it up while I'm testing. So this was a good compromise. It's not like an absolute piece of junk or anything. I think, Canadian Tire doesn't actually make inverters, but they have a lot of clout when they're ordering out of China. So they probably go to a supplier in China and kind of give the specs that they need and then order it and get them to build it. Also, one thing I liked is it came with a 3-year warranty, and Canadian Tire has stores all over Canada, so you could actually take it right back to the store rather than buying online from some kind of no-name Chinese inverter company. So I thought it was a good compromise. So let's go through some of the specs and then we'll give her a test run. On this end, this looked pretty good to me. A couple big lugs here to attach my wiring to, and then it's got dual fans on the back. And also, I think from what I was reading, that these fans don't come on unless you're drawing some power through them, so they're not a type of annoying fan that's always going to be running. Also, I kind of like that it was a flatter case. Some of these 3000 watt inverters can get pretty tall, so I want to mount it on a board, kind of a wall inside my storage compartment. On this end we have two outputs, and they can handle 16 amps each, so 1800 watts each, or combined 2600 watts, or yeah, 2600 watts, or no, combined 16 amps each. I think combined they can handle the 3000 watts. But one feature that really intrigued me and what I wanted is you can hook up a wire and you can hardwire it right to my transfer switch that I already have installed in the RV, and that'll make it very simple that way. Also, if I'm testing something, I can hardwire it to that. And then it's just got a display over here, a couple USBs. The kit also came with a bunch of wiring included, which was kind of nice. There's a couple 3-foot zero gauge cables, all nicely installed with lugs, and they even have a fuse in there, a fuse link. Also, it has a remote on-off switch and some information on the display. So let's hook it up and give her a try. So I've hooked it up to two Lion Energy lithium batteries wired in parallel. Now each of these batteries is capable of putting out 150 amps discharge rate, so it'll be a perfect mate for testing out this thing because it can take 300 amps. So I've wired them in parallel into the end here. And then on the business end here, we've got the remote display plugged in, and it comes with, I think, 20 feet of cable. Looks like the Ethernet cable. So we'll just turn it on here, show you the displays, Takes a minute to boot up. So 13.76 is what it's showing. Both those batteries are fully charged. And if I press this, I get next, it's showing me 115 volts. So the inverter AC voltage is 0 watts. It's a watt reading. And it's showing temperature 25 Celsius, I guess. Wow, it's pretty loud on this one. Whew. Okay, seems to be working. So let's plug ourselves in a load. First test I want to do is check out the idle current. So what this will draw, if it's actually not powering anything, just turned on what the actual device draws. So I got a clamp on there. Meter for amperage. I'll just turn on the unit. Get a close look here, see what we got. Looks like it's drawing right now about 0.6 of an amp, so barely anything really. Let's turn on this. Let's put it on fan mode right now. That's drawing 48 watts. Let's see if we got a pure sine wave. I got an oscilloscope set up here. Give her a stop. Yeah, that looks pretty good. Pretty smooth looking pure sine wave. Let's crank up the heater a bit. Go up to 600 watts there. Oh, so you could hear the fan turn on. That's what the fan's going to sound when you're powering something. Turn that back down, see if it turns off. Yeah, fan comes right off. So I kind of like that it can power just little loads without the fan cranking on. It only starts to crank on when you turn on a bigger load. So let's turn this heater full blast. See what we got. 1367 watts. We'll check our sine wave again. Yep, still nice and smooth. Let's see what kind of current we're drawing out of the battery here. Looks like 124 amps. Seems to handle that no problem. Okay, so I got a heat gun on max. Turn this thing on now. It's on max. We're showing 2430 watts. See what we're drawing out of those batteries. 246 amps. Seems to handle it no problem. Voltage 11.7. So the voltage range on this low voltage cutoff I think is 10.5 and high voltage is 16. I'll go through the specs in a minute. So the voltage does start to sag at 2100 watts here. Temperature's rising. You can see instead of 115 volts I'm only getting 111. I'll step it up. You can see it drops to 107 and I'm at 2300 volts. So yeah, once you get past 2000 it starts to get a little saggy on the voltages there. And 13. Go back up to full on the other heater again. See it drop down 106. We're not at 3000 watts yet, we're at 2375. We're drawing out of those batteries. 248. Next, let's peel the covers off this and actually get a peek at what's inside this black box. So I popped the covers so you can get kind of a look inside how they've designed and built it. And it looks pretty good. It's basic, simple design. See over here they've split the DC input into 4 different wires and 4 different sections. Looks like all the capacitors are 105 Celsius capacitors. They all look like pretty good quality capacitors. Board looks pretty decent. Got a big long negative bus bar here. Attaches to 4 more wires. Not really a big fan of how they've just put everything together here. You can see where you could get loose connections if those bolts start to back off, but they've probably used nylock nuts and locking rings on there. There's your fans there. Down in here we got a little fan control board. Then once it's the DC's chopped up, there's a bunch of FETs over there, chops up the DC. Then it gets re-rectified. You can see these are 105 volt. 105 volt caps. These are 25 volt caps. And there's a bunch more transistors on this side responsible for taking that DC and then turning it back into AC. And then we got over here, wires seem to be protected by a second layer of braiding. Those are your AC wires. There's your 2 AC outlets, and then the outlet for running straight to a panel, and your display over there. Looks like we got some big aluminum heat sinks on each side, and even the case is aluminum, so not too bad for a economically priced unit. Here's some of the features, specs that I liked. DC input range 10.5 volts to 16 volts. DC input current 300. So they're showing the AC outputs here. Single outlet 1800 watts, 16 amps. Combined AC outlets 3000 watts, 26 amps, or the hardwire terminal 3000 watts, 26 amps. It also has a 6000 watt surge. Efficiency is pretty low, 85%. That's just okay. Some of the better inverters are going to be up 88%, 90%. No load current says less than 1.4 amps DC. We saw it at about 0.9 something, so we had about right around an amp. Anything else here? Low input voltage alarm, 11 volts. Low input shutdown, 10.5. High input shutdown, 16. We already talked about that. Over temperature shutdown, yes. Overload protection, yes. Short circuit protection, yes. And the weight, 16, almost 17 pounds, 7.65 kilograms. So anyway, it's good for my needs. My main need for this is to test batteries. I need a good inverter so I can put a good load on some of these lithium batteries. Also, I'll wire it into the RV. You can look forward to that probably sometime late September. Once we're just about to get out of this RV park and back off-grid camping, I'll probably go and wire this into the RV and wire it into my transfer switch, so I'll have a video on that. In the meantime, I'm going to keep it like this so I can test. I got some lithium batteries on the way from a few companies to test, and I have some New Line Energy batteries to test in a little while. So main thing is it's a relatively cheap inverter compared to, you know, some of the ones on the market like Magnum and Victron. You know, they're going to cost a lot more and be a lot more robust, but for my needs this would be good, and for maybe someone that's looking for an economical system it might be pretty good. The main detail that sold it for me is it had the 3-year warranty, and it's at a place that I can easily go back and get that warranty at a physical store. Till next time, Ray from loveyouRV.com. Cheers everyone.